Have you ever wondered what really happens after a scientist gets their hands on some data? You know, it's not always just someone in a lab coat squinting at a screen. No, the real story is this incredible hidden journey. A journey on data superhighways that ends in these giant, humming rooms full of machines. Today, we're going to follow the secret life of a single brain scan as it travels to a supercomputer to unlock its secrets. So let's just get right to it. What on earth does a brain scan have in common with a supercomputer? Well, the simple answer is a ton of data. But the real answer? Well, that's the amazing journey we're about to dive into. Okay, so first things first, we have to wrap our heads around the sheer scale of the problem. Modern science, especially in a field like neuroimaging, doesn't just create a little bit of data. It creates an absolute mountain of it.
Check this out. A single brain scan from just one person in a study can be around 226 megabytes. Now that might not sound like a lot, right? It's like a few songs. But what happens when your study has hundreds or even thousands of people? You are suddenly looking at terabytes and terabytes of information. Your laptop would just give up.
So how in the world do you get that mountain of data from the scanner in the lab to a computer that's actually powerful enough to make sense of it all? I mean, you can't just attach it to an email or use a regular file transfer. Nope. You need a dedicated data superhighway. And that's where a tool like Globus comes into play. You can think of it like a specialized armored truck for your data. It's not just that it's fast, it's that it's super reliable. It literally checks to make sure every single piece of data arrived safe and sound, uncorrupted. And if the connection drops, it just picks up right where it left off. This is the professional tool for a professional grade problem for sure. But hold on, before we hit send, there's a critical pre-flight check. You have to package the data. See, sending one giant box is way more efficient than trying to mail thousands of tiny, separate envelopes. It cuts down on all the extra work and, really importantly, lowers the risk of something getting lost or corrupted. Okay, our data has made the trip. It's arrived safely. Now we get to the really cool part, the High Performance Computing Cluster, or HPC. Let's pull back the curtain and see what makes these things so different from the computer sitting on your desk. The whole philosophy here is just brilliant. Your laptop, it's like a Ferrari, one incredibly powerful, specialized engine designed to do things super fast. But an HPC, that's more like a fleet of thousands of Toyota Corollas. Individually, they're just standard cars, but working together, they can move a mountain. It is all about massive parallelism. And since it's a shared resource, you can't just install whatever you want. It's like a public library. You have to follow the rules and your time is limited. And then inside that fleet, you've got the specialists, the GPUs, the graphics processing units. And I just love this analogy from the source material. They're like idiot savants. They are blindingly fast, but only at very specific things, like the millions of tiny, repetitive calculations you need to process images. So for the right kind of job, they give you this just unbelievable speed boost. So if you can't install your own software, how do you run all your specialized scientific programs? Well, the answer is something called a container. The best way to think about a container is like a perfect little software bubble. It holds your application and everything, and I mean everything it needs to run, all bundled up together. This makes sure your analysis runs exactly the same way every single time without messing up the shared computer for everybody else. Now, you might have heard of a tool called Docker, which is super popular. But on most of these big supercomputers, they use something different, called Aptainer. And the reason why is simple, but it's absolutely critical: security. Docker needs admin-level privileges to run, which is a huge no-no on a shared system with sensitive research data. Aptainer, on the other hand, is designed from the ground up to run securely with just your normal user permissions, making it the perfect tool for this kind of shared environment. Okay, so the data is there, the software is ready to go inside its little containers, so you just click run, right? Not quite. On a shared machine with maybe thousands of other researchers, you have to get in line. Everybody meet Slurm. This is the traffic cop, the bouncer at the club, the air traffic controller of the entire supercomputer. It's a job scheduler, and its whole purpose is to manage the line, making sure every researcher gets their fair share of computing time. You don't just tell the computer what to do. Nope. You submit a request to Slurm, and it decides when to run your job. So this is the crucial part. You don't just run a program, you submit what's called a batch job. You can think of it like ordering a custom cake. First, you write down the exact recipe, all the commands for your analysis. Then, you tell the baker what you'll need: I need 12 CPUs and this much memory for about 5 hours. Third, you hand over your recipe. And finally, you wait. You go do other things, and the system just emails you when your cake is ready. It's a completely hands-off process designed for these massive, long-running tasks. So we've navigated the whole setup, the data transfer, the queue. After all of that hassle, what's the big payoff? Well, this is the moment we've been waiting for, where all that complex preparation leads to something spectacular. Just look at this, a really complex neuroimaging analysis, the kind of thing that would take a full 24 hours to run on a powerful, high-end desktop computer, is finished in 5 minutes on an HPC using a GPU. 5 minutes. That is not just a little bit faster, that is a complete and total game changer. A job that used to tie up a computer overnight is now done in less time than it takes to brew a pot of coffee. It's incredible. And this is why it all matters so much. This kind of power isn't just about convenience or saving time. It unlocks a totally new scale of science. It means researchers can finally analyze data from thousands of people, not just a few dozen. They can run simulations of things like galaxies forming or proteins folding that would be literally impossible on any other machine. It fundamentally changes the kinds of questions scientists are even able to ask. So if there's one really crucial point to take away from this entire journey, it's this. A supercomputer is not just a faster laptop. It's a completely different kind of scientific instrument, just like the Hubble Space Telescope or the Large Hadron Collider. It enables a scale of research and discovery that, not too long ago, was basically unimaginable. So, from a single brain scan to a massive supercomputing cluster, our data's journey is finally complete. And it leaves us with one last, really exciting thought. With this incredible power speeding up discoveries in medicine, in physics, in climate science, and beyond, what mysteries will we solve next?